Hi, everyone. Thank you for joining. My name's Jake Thomas. I'm a principal engineer at Okta working on replatforming the defensive cyber operations team onto Snowflake. And my background is very much not necessarily a security context, but rather data platform and engineering. So worked at Shopify doing data platform stuff for robotic fulfillment, worked at CarGurus doing data platform stuff for product analytics as well as data products, and worked at O'Reilly doing BI and all kinds of other stuff between. Before we dive in, just wanted to do a high-level kind of agenda of what we're going to discuss. So first and foremost, we're going to set some context on the defensive cyber operation team and tools and use cases at Okta. We're going to dig into why we chose Snowflake. We're going to kind of venture into the technical specifics of what we're doing and what we're doing now versus when we started, or what we've learned versus a lot of our assumptions. We're going to talk about newfound functionality that we're excited about, specifically around Snowflake stuff, and then general other learnings along the way. So, like I mentioned, I work on the defensive cyber operations team at Okta, and Okta is a security company, and the security company has a security team, and within that team, the defensive cyber operations team is responsible for detecting and alerting and triaging and responding to threats for Okta as the company, as well as all of Okta's customers. So, as I'm sure you can imagine, we have some pretty interesting regulatory mandates and compliance challenges with what we're doing. Obviously, a whole class of those right now cannot be accomplished because we work in FedRAMP High environments and we can't use Snowflake there. With that being said, we're actively moving towards those. So one side of Okta is all the regulatory and consumer compliance stuff, right? CCPA for our customers, GDPR, stuff like that. An entirely different side of regulatory mandates within what we're doing is the public sector. So IL4, IL5, FedRAMP Moderate, FedRAMP High, depending on where we're putting Okta. Obviously, we want to detect and respond to threats in all of those environments. Within our team, it's broken out into several sub-teams, the red, blue, purple teaming stuff, adversarial engineering versus blue team, threat research to share with our partners, identity defense for our customers, etc. And that comes with a very interesting, broadly niche, if I can say that, skill set. So the folks on our team are highly technical, but their backgrounds are super broad. They have a ton of domain context across those regulatory landscapes, obviously. And from a tooling perspective, like a lot of them have used Elasticsearch, a lot of them have used Splunk. Not necessarily all of them have used SQL. And that's, kind of a nice tool to have when you're using Snowflake. From a workload perspective, our primary workloads, probably 95% of the time, are getting logs in really fast, detecting potential threats in those logs, responding to them, and enriching them for downstream use cases. A secondary workload is a whole class of research and threat intel and basically data sharing with partners, and then operations within the team. How to be a little meta and use the data that we're collecting and acting on to make ourselves more efficient. And then finally, the tertiary use cases are like security analytics and compliance stuff and data science and model training to push back into the products and stuff like that. So this comes to why Snowflake. There are definitely tools to handle some of these use cases that have been around for a very long time. And the first reason is the workload flexibility for us. It's a very large company with a very large set of data and really broad and diverse needs. And Snowflake is a really good tool for kind of centralizing those workloads and centralizing those needs onto, I say a single place that's not actually that in reality, but it's drastically simplified compared to the alternative. So, for example, low latency, short look back workloads, traditional SIEMs do that pretty well. Medium latency, short or medium look back workloads, we have a whole host of options, and it's like a matrix of systems. AWS, you can do the same thing in 25 ways. And, that's kind of our starting point. So consolidating those saves a lot of cost, saves a lot of complexity, makes them run better longer. And finally, the high latency, long look back stuff like year over year analytics on, threat intelligence, or, an IOC comes in and we want to go back a month or a year or whatever. That's an entirely different class of workloads. And Snowflake makes those achievable within a single high-level umbrella. So I say single tool set. Again, it's not a single tool set, but it's drastically simplified and drastically fewer than what existed previously. And along those same lines, from a data perspective, we have enormous amounts of fragmentation within our data sets, and it helps reduce that fragmentation and drastically streamlines whether it's development velocity, whether it's response velocity, et cetera. So, all of these questions are super important long before something actually happens. So what data sources do we have available? Where are they? How do I get to them? When do they land, et cetera? Like, a lot of that is very hard and, again, super fragmented. For example, this third bullet point, which AWS account do I go to? Well, we have, hundreds of them, quite literally. Which CloudTrail logs bucket in one of those accounts or environments? Like, we have, in some cases, like 6, 12 different buckets in one particular account. So centralizing those and making those accessible from a single place is, a huge velocity uplift, obviously. So as we're starting fresh with a lot of this, it's a really good opportunity for me and our team to basically generate, use what we're doing and simplify, but also, since we're using a single set of funnels, a single set of systems, we can just put metadata everywhere. And that helps us, as we'll dig into later, be more efficient and know what things happened within our incoming log sources. And it allows for self-service ability, like detection and response engineers can know the sources that we have, know the last time it was loaded, know the average velocity of, or average files landed by hour, and see for themselves if something's gone wrong. A third point to the why, there are really big organizational and market opportunities for just sharing data. So data sharing within our company, we have several Snowflake accounts, but do we really need to pay a third-party SaaS tool 3 times to land it into 3 different Snowflake accounts? Definitely not. That's the reality when we started, which is drastically improving. Capability sharing. So what we're doing internally, sharing that with our customers at some point in the future, perhaps, is now doable. We wouldn't have wanted to do that before. And intelligence sharing drastically makes that much easier to partners. So we're benefiting ourselves, we're benefiting our customers, and we're benefiting our partners. And finally, the subject of all the talks is, being efficient, advancing cost efficiencies, yada, yada, yada. Again, data retention, having 25 copies of the same data is not cheap. Not being able to scan a year of data in a SIEM is a problem for response. So we're shrinking data retention costs, but also reducing data retention. That's a huge multiplier for a cost perspective. Generating a ton of metadata so that we can drastically and continuously improve how our systems are working is a huge cost multiplier and huge benefit to the company. And finally, having cost controls for these systems in the same place or a drastically reduced set of places is a huge multiplier for cost. So diving into the technical stuff, before we even started, we came up with a set of, pretty clear principles of you can use Snowflake in 100 ways, but what are our systems going to be predicated on from the foundation up? And these are some that we came up with. So we wanted visibility. We wanted to know what everything is doing at all times, not only from outside systems, from a logging perspective, but also all of the systems that are collecting those logs, all of the systems that are transforming them, all of the detection systems, all of the workflow systems, et cetera. So starting with ingest, working to normalization, working to detections and response, and then going out from there has been a huge boost. I like control. I want to keep it. And therefore, some of the architectural decisions that we made are centered around retaining control and retaining the ability to generate the metadata that we need. So keep that in mind. Be efficient for the business with a fixed resource. We want to do the most possible things that we can and satisfy the most possible use cases. And if we're not efficient, then we can only get a fraction of the way there. And finally, for the stakeholders that are using our systems and using our data, We want to be safe for them and for us, quite frankly, to not make mistakes. And if and when the mistakes happen, because they do, not to wreck our data, wreck our systems, wreck our deployments. So we've built it around safety and intuitiveness for the people that have to use it, again, from a data perspective as well as tools. So this is an example of like one of the first tools that we made internally. So all of the Snowflake objects are represented as Python objects. They're all type annotated because it's really nice for people that are going to use them to have VS Code tell you what you need to write rather than need to know every SQL statement along the way and your options within that. So like, what's an enum of warehouse sizes? Like, we want VS Code to say that. We don't want people to jump through 3 pages of documentation. So we've centralized a lot of that. Digging into this, like you can see it's dot notated table dot column names. That's an array of column names, exactly like you expect. We have a whole bunch of like row level metadata that we append as stuff moves, and we can reference those by metadata column names. Like these are the columns that automatically get appended. In the case of like a table level create statement, we can say table level object dot create, and that's the statement. Create or replace, create if not exists, et cetera, on the permutations there. What's the SQL that I need to run to recluster this table? How's the table cluster? Is it transient? Is it not? What's the data retention time in days? Yada, yada, yada. It just goes on. So it's an easy example of that as well. Like this table is clustered by the tri-level cluster key, recipient account ID, AWS region, data expression on event time, warehouse metadata column names, yada, yada, yada. Create if not exists, or replace, or just create. So the nice thing about this is we can share these objects. So these objects, once defined, we can share them with our ingest systems. So the systems can automatically ensure the state of the world. They can automatically reconcile, these tables if they diverge, as well as downstream systems can use these same objects and reference a fully qualified namespace directly. So from a Snowflake perspective, kind of high-level principles, not necessarily from the architecture, but rather Snowflake specifically. Source data shared, all stakeholders, obviously some things are masks where they can't access certain tables, but as a general rule, we want all the data that we ingest to be shared across these teams. We isolate teams and applications by a database, so we can maintain really strict and strong ACLs there. And as you can imagine, you don't want a red team and a blue team sharing their data or sharing their systems, because that would wreck the entire point. So do the least work possible, be efficient with Snowflake resources, saturate stuff, and collect metadata. So this is an example of just pounding data into a query tag. So this is a really nice mechanism to basically tie jobs. So a job can be a single SQL statement, but it can also be like 10 SQL statements. So by being able to tie a job to all the SQL statements, we can then optimize. Hey, it's doing 10 SQL statements. This looks like duplication. We can cut it to 4, for example. We can also tie external instrumentation that we're generating to all of the Snowflake account usage tables. We can say, hey, this source S3 file, whatever, was loaded to this destination with this load system at this job UID, using this warehouse and all of the other goodies that are in account usage. And again, this is a high-level diagram of how we just separate our data. So again, focus on ingest, and we'll get through this shortly. But one of the biggest surprises that I had initially, going from a data platform team to a data platform for security, is like, it's really nice when you don't need infrastructure in the world of security, because then you don't need to basically instrument or be too meta on yourself, because there's nothing to comply with, for example. Like, make sure that it's not public facing, but like, we're not patching Lambdas. We're not doing a ton of work that these systems would have otherwise required. So we heavily lean into Lambda for job execution, for dependency management. We heavily lean into AWS resources there. And the byproduct of that is like, for spiky workloads or very differing use cases, everything's auto-scaling. So, and it's separated by source. So CloudTrail logs rip in the morning and then taper off. Like, we're only spending what we need to there. And especially with container images being cached very well in Lambda and all of the things being ARM64. It's a whole lot of Python, but we know at any time that we can move it to Rust and drastically improve those costs too. single-digit thousands per month is not worth optimizing from our time perspective. From a build and deploy perspective, everything's declarative, and it's all infrastructure as code. So we took a very naive approach early on, just land everything in S3, normalize it with multi-cluster warehouses, copy into staging tables, merge where it needs to be. It's simple, it's easy, it's definitely easy to get started with. At our scale, we ran into both challenges and opportunities. So this is what that system looked like originally, right? These are just random, third-party data sources. Obviously, that list is like hundreds of those and not a dozen or whatever. So the challenges here for us, same story every time. Data sources are highly variable. Is it CSV? Is it TSV? Is it JSON? Is it JSON-L? Is it not? Is it something totally weird? Whatever. It happens. And the more data sources you have and try to centralize, the more you run into this. And the more variable those source systems are, the more challenges we run into. So, for example, one of the first challenges not a first challenge, but first significant one that started causing us to rethink a lot of things, CloudTrail logs. It's a kind of miserable source to load when you have a 16 meg variant maximum. So CloudTrail logs are buffered by time or size, with the size maximum being 50 megs. And within those files, it's a single object with a single key records with an array of objects. And there's no way to get that into Snowflake once it exceeds 16 megs outside of pre-processing. And obviously, that was a bit of a light bulb moment. So another thing we ran into is some of our data sources, when they get to a certain scale, and basically everybody has this problem, but the scale is very isolated to the company. At ours, you don't know how much you're going to spend for a data source before you start loading it, right? And transforming it and doing stuff. And when we spend, a week or two or whatever, trying to get a data source in, turn it on, it spends $1,300 a day. And we aren't getting immediate benefit from that. It requires a bit of a rethink in terms of how do I get insight into how much is this source going to cost us? How many files will it blow up the ingest, virtual warehouse queue? Will I need to bump multi-cluster warehouse sizes? Am I going to need to bump my warehouse sizes, period? There's some, the systems that we build, we want to deploy, again, across those regulatory boundaries, and we can't do some of the stuff, again, there. And then as you fiddle and as you optimize and as you do stuff, we found that a lot of our warehouses, specifically on ingest, again, were just not saturated. And this is the result of starting to load VPC flow logs. It was 40% of the company's VPC flow logs at a rate of 40 to 50 billion events per day. Again, one of the sources of hundreds that we need to load was a $1,200 increase. And surprise, this is what you're going to spend to get this in. So V2 on ingest, and again, we'll go far downstream from ingest, was do as much pre-processing upstream of the final ingest to Snowflake, build a very well-structured, snappy compressed Parquet bucket upstream. Again, crawl it for as many metadata and statistics as you possibly can. So what content is in it? What is the, row size? If you need to pre-process anything, that's where we're doing it. The volume within files, the volume of files, the rate at which they land, etc. And then accumulate those files, compact them, and then gatekeep ingest based on the metadata that we're gathering. The metadata, as you can probably imagine, goes to Snowflake. So we are doing a ton of pre-processing and analyzing that with Snowflake in a bit meta fashion. And again, copy into. So system looks a bit like this. It also opens up a lot of opportunities to standardize. So all of our Snowflake ingestion is the same exact auto-generated copy into statement from whatever source, because it's all Parquet. And it makes it very efficient and very easy to do that. We only have one type of load statement. It also means that we can move from copy into statements to Snowpipe to Snowflake streaming pretty easily, because we can just fire those at different areas. So wins, as you can imagine, we have much better visibility. We have much better metadata. We can use the data that we're crawling effectively to communicate upstream and up the org in terms of priority and will this be worth loading into Snowflake or having for the DARE team, because it's going to cost you this and we need to do this accordingly. Ingestion has been standardized and we saturate all the things. So After this point, that ingest cost has remained pretty constant, relatively speaking, and we've just like pounded data sources in because a lot of that warehouse inefficiency, a lot of that undersaturation has moved elsewhere. We're basically breaking in the lower bound, like a single cluster extra small into like a million chunks and using what we need to there versus keeping it up and a lot of overhead running. And then this is just like a log source dashboard. I think this is a little small. Ingest cost by hour, estimated ingest cost by hour, bytes per hour, table ingestion frequencies, on and on and on, files loaded, stuff like that. So from the detection and response component of this, one thing that we chose to do very early, again, is like not use Snowflake whenever we could because we want to do a lot with it and we want to be efficient with our use of it. And that led us to use, instead of scanning a table and continuously scanning the last day's worth of data for each of these sources, we're heavily leaning into change streams and heavily leaning into change deltas. So every single signal and every single corresponding threat has a stream at which we consume with a task at whatever rate and frequency we want. And, obviously that's heavily dependent on how often the table is loaded. So signals are normalized, they're built into composites, they become alerts, and then we, track on those both signals and alerts and integrate with some of our detection workflow systems. So high level, again, looks kind of like this. Change streams and tasks turn into signals, which turn into alerts. So tables loaded, fast path decline phishing event has a change stream, continuously reading deltas, continuously harvesting signals, and then continuously building alerts. From a detection perspective, all of it is written in Python, so it's the primary interface with our detection and response engineers. It's a language that they know very well. It's a workflow that they know very well. And within every single detection, obviously we have a unique ID. Obviously we have a technique ID associated, a description, severity. How should we respond to this? Those are represented as basically base searches within those streams. And we have post-detection stuff and playbook stuff there. Something that we can do now, and was a little bit difficult before, is where all of this is consolidated and all of this is centralized. We're building metadata, and all of the signals and alerts and workflow information goes into tables that we can now put into dashboards and track ourselves over time. So we can do a lot of analytics on every log source. We can do a lot of analytics on, what false positives are we spending too many cycles on as a team and how to mitigate those. We can do analytics on our relative severity across all of these sources, MTTR. So coming into functionality that we're obviously pretty excited about, Iceberg tables. So at Okta, there's like an entire set of kind of data classes, I guess you can say, where it would just, the cost benefit equation isn't really worth it to us to spend that money ingesting to Snowflake, because we'll use it once in a while in the case of an incident, for example, and, sometimes maybe never at all. So like taking the cost continuously on those does not make any sense for us. And, some of these sources are just absolutely enormous. DNS level logging, VPC flow level logging, etc. So Iceberg is amazing. We're very excited about it. I've had it open for a while. It's looking very promising. External volumes and the specifically like managed Iceberg tables, super excited about. You can build your data lake in Iceberg with Snowflake with managed tables, or you can do it with Glue. It doesn't really matter. Secondly, search optimization, and again, especially on Iceberg, is looking really, really good. Field-based indexing is awesome. Point lookups on Iceberg, awesome. There's a ton to be said here. Snowflake can speak to this better than I can, but we're super excited about it. And finally, dynamic tables are looking really, really cool. So another thing we've had open for a while and continuously building like high-level kind of user-level views across all of our customers or across all of our employees or across all of our assets is a really, really powerful thing. Aggregating sources is a very, very powerful thing. And not needing to set up infrastructure, Airflow, whatever app is to be, to maintain these DAGs and maintain these schedules, and having them up to date continuously is really huge for us. So finally, some of the next steps, aside from the stuff that we're excited about, because that's going to be a short-term next step, is just embedding OLAP workloads everywhere. So as far upstream as we possibly can, and then spitting that data back to Snowflake is a very powerful thing. So a lot of the times our logs are jumping networks or jumping availability zones or whatever it happens to be, like 3 times, 5 times before we get it to Snowflake, or even get it around our environment, let alone jumping another one into Snowflake. So embedding that as far upstream as possible, and then generating our signals, generating, a whole bunch of insight alongside of running applications or alongside of assets is a very big thing. So that's it. Thank you.